A couple notes here before we start the similar triangles portion. This whole packet is dedicated to things you are probably going to see on June 20th when you take the actual exam. If I had to start ranking these, similar triangles would be in the top 3 as the most amount of problems you would see. Now, I say most amount. There's only 35 on here, so when I say most, I'm probably talking about 3 or 4. All right, but similar triangles would be up there as far as the topic that it's going to occur the most. So a couple notes here before we start. Let's review 3 ways to prove triangles congruent. All right, sorry, similar. 3 methods of proving triangles similar. What do you got for me before I lead into these questions? Nick? Angle. That's the big one. That's the one you also use if we're doing any type of similar triangle proof. It's automatically going to be angle. But we did have 2 other methods I need you to be responsible for. Will? Okay, side, angle, side with the tilde there, yes? What's that mean? The angle in between them are congruent, but the sides are, don't say similar, sides can't be similar. Sides are proportional, they're in the same ratio. And then we had a third one where I don't need any angles, and that would be side, similarity. All 3 pairs of sides are proportional. All right, so now that we went over that, these should be, hopefully, let's see, smooth sailing. All right, take a look at 1. Mark your diagram with all the givens. You got angle H congruent to RDO. And then we have some lengths. RD is 6. RO is, nope, RD is 4. Come on, one job. RO is 6. OH is 4. What the heck's the length of CD? All right. This is tough. Everybody knows this is similar triangles because that's the topic I put under day 3. But when you're sitting there in Gym B in the exam and you're going to say to yourself, what do I do here? How am I going to know? How are you going to know this is a similar triangles problem? Because anybody see the word similar triangles in there? I don't. So how do I identify that this is a similar triangles proof? By what you're given. Anybody see angle in there? You got a pair of congruent angles. Where's the other one then? Where's the other one? Angle R, right? Because it's shared by both. So does everyone see in both triangles you have angle? Therefore, they're similar. And that gives us the right now. Oh, the triangles are similar. The sides are in the same proportion or same ratio. That's half the battle. Here's the other half is what's the correct proportion. Full sides only go in the proportion. Full sides only. I should not see X by itself. That's not a full side in either of those 2 triangles. I need full sides. So somebody start this off somewhere. Somebody give me a full side length, please, so I can start this proportion. 13, full side. Oh, nice. Going hardcore on me. Nice. 4 plus X, which is CR. Good. Now it's on, what does CR match up with in the small triangle? And if you're struggling, I get it. Here's my little trick. Does everyone see that CR is across from angle H? So its corresponding side should be across from the angle that's congruent to H. That's how it works. Whatever 2 angles are congruent, their corresponding sides are directly opposite each other. So in the small triangle, what's the length of the side that's across from the other angle that's congruent to H? How long is that side? 5. 6. Good work. So X plus 4 and 6 correspond. All right, I have X plus 4. What's the other side length from the big triangle I know? Full side length, 7, 10. And the 10 would correspond with DR, 4. Look at the congruent angles and look across. Those are the sides that match up. Go ahead, quick cross multiply, and I'll ask somebody what the answer is here. And yeah, you're right. This proportion's simple to solve. We got to get there. We had to know this was similar triangles by angle, and then what sides do match up. So what's the value of X in here? That missing side, 10, 11. Yep. Ooh, almost had it there. Your period 7 counterparts also guessed the correct slide transition last class. Gave away some other random stuff. All right, we all good on this one? It was slide left, and they got slide left. I gave them top 3. It was, I think, their second one. Slide left was the transition. All right, next up, I got AD is 24, DB is 12, DE is 4. What's side X? AC. And also in the givens, it tells us AC is parallel to DE. Guys, how are you going to know this is a similar triangles proof or question? Anybody? Because that's going to be, yeah, I get it. It's all similar triangles day, but it won't be on June 20th. Will, enlighten us. Maybe.
Do the parallel lines show you that the triangles are similar?
True, but how do I get there? There's a gap in between how I get from parallel lines to similar. Anybody see angle, angle? Give me an angle. Give me a pair of angles that are congruent already. Angle B, reflexive, right? And this is also good review. What type of angles are formed by those parallel lines that are also congruent? Nice, using that word, corresponding, like A and EDB. So I know the triangles are similar because of angle, angle. Now the sides are in proportion. Give me a full side that you know. Full side from one of the triangles. 6, give me a full side. 36, going big time, huh? Showing off. 36, yes. 24 should not appear in your proportion. That's not a full side. 36 corresponds with 12. And if I'm going to use 36, I need another side from the big triangle, which would be X, and that corresponds with 4. $13 when you're ready. 12, good. Whew. Right around. Questions? And look, the people, whoever make these Regents up, they want you to fall in traps. Why they're that nasty, I don't know. But I guarantee if 24 appears somewhere in here, that answer's here too. Okay, so you've got to take your time. All right, the traps are there. Whew. All right, speaking of similar triangles, I'm going to tell you these two triangles are similar. What side lengths back that up? So I'll do number 1 with you, even though it's wrong, and show you how I know it's wrong. So if AD is 3, AB is 6, AE is 4, and AC is 12. How do I know that those triangles wouldn't be similar with those lengths? Does 3 over 6 equal 4 over 12? So they're not in the same ratio. So there's no way those can be side lengths. So go ahead with the remaining 3 and figure out which side lengths would put them in the correct proportion. All right, which grouping of side lengths would give you similar triangles? If you're not done yet, keep working. 8. Choice 4. 2 over 6 equals 5 over 15. 1/3 equals 1/3. You and your group, I'll give you about 3-4 minutes. Finish up the similar triangles questions. 4, 5, 6. Go ahead in your group. Finish up the similar triangles questions. We'll regroup in about 3 or 4 minutes. Because we still have to get the dilations here. All right, number 4, which one could you justify using side angle side? For me, right away, I'm getting rid of 3 and 4 without even noticing any side lengths. Because if I do C, that's not in between 6 and 8. So it can't be side angle side with those. And going between 9 and 12 and 8 and 10, well, which 2 are in the same ratio as 6 and 8? 9 and 12. All right, so choice 1. All good? All right, keep trucking. Which one are similar? Number one, they are not similar. That's side angle side. Right angles in between. Number two, that's angle angle. Three, that's a hot mess. Right? Not even the sides are in proportion. The angles aren't even in between. So you can't even get messed up either way. Why is four similar? We could say side angle side similarity, or Nick, go ahead again. These triangles are congruent by our side angle side. So if congruent triangles mean similar triangles every time. Not the reverse, though. Not the reverse, but that way, yes. And then finally, were these two triangles similar? I had S congruent to Y, and we had RS is 6, ST is 14, XY 9, YZ 21. Similar? Yeah, these are similar. It had the angles congruent, and the sides around them were in the same ratio. So by side angle side similarity. All good, similar triangles. Hefty topic on there. When I say hefty, maybe four tops, but there are only 35 on there. So. Dilations to finish it off. I thought I was going to be done by now, but we had a little extended vote, which is fine. Which, by the way, as I look around, as you guys were working on that, congratulations. You're out of the top 6. There's at least one in every group represented. Nice job. Sorry, guys. I don't know what to tell you. Get your game up. Worst pair in the nation over there. All right. So here we go. What group is going to represent, huh? And bring it home, huh? What group is going to bring it home? And the question is, if we get to the top 3, will your own group vote for you or not? We'll see. We'll see. Okay, here we go. Moving on. All right. Sorry I even brought it up. But it was interesting how the 6 are dispersed here. All right. Dilations. One note I want you to take on dilations, and that is pay attention to where the center of dilation is. Okay? It could be in 2 spots. First spot it could be is the origin. I dilate around the origin. All right? If that is the case, if the center of dilation is the origin, you can multiply coordinates by whatever the scale factor is. So if the scale factor is 3, I can multiply every coordinate by 3, and there are my new coordinates. All right? But that is only if it's around the origin. Where's the other place you could dilate? Remember this. A point on the line being dilated. Who's going to dig deep and tell me what happens now? So I ask you to dilate a line, but the point I want you to dilate around is already on the line. Anybody remember what happens? Nothing. What do I mean by nothing? The line remains the same. Doesn't move anywhere. All right? So a point on the line being dilated, line remains the same. So please pay attention to where you're dilating around, because it's going to be one of the 2. Let's answer number 10. I'm going to dilate line L by a scale factor of 2. There's the equation of line L. What's the equation of line M? All right, forget about dilations right now. We've talked about this all week since we started reviewing. If you're asked to write the equation of the line, what are the 2 things I'm going to need to produce for you? I need the slope, and I need the y-intercept. All right, let's get both now. I'm dilating a line. That doesn't mean it's getting bigger or smaller. That just means it's moving closer or further away from the origin. So these two lines are going to be what to each other when I dilate it? Parallel, meaning their slopes are the same. All right, you guys better work right now. What's the slope of that line? Because it's remaining the same. If you tell me 3, get out of here. All right, you know it's got to be in y equals form first. So get it in y equals form, then I'll ask somebody what the slope is. It is not positive 3. Never mind, it is positive. God! God, I don't like any of you. It is 3. How am I teaching honors? That just goes against every rule I've taught you, too. That just don't look, and it's the, because you have to divide by -1 at the end. All right, it is 3. Congratulations. Y-intercept now. That won't stay the same. All right, it only stays the same if I'm dilating around a point that's already on there. What's my y-intercept on this line? 4, right? Or -4? Which one? -4. And since I'm dilating around the origin, what can I do with that scale factor of 2 to find my new y-intercept? Multiply by the scale factor. So my new y-intercept, -8. Put the 2 together. Y equals 3x minus 8. Whew. You take a look at the next one on your own, 11. Actually, why don't we finish class up 11, 12, 13 in your groups. 11, 12, and 13 in your groups. And then we'll go over the answers, and if we get to the last one, so be it. If not, it's not a big deal. We got days of review.
Yes.
For number 11, they remain parallel, so your slope should still be 3/2. You multiply your previous y-intercept by 3/4, and we get choice 4. Whoa, relax. 12, I'm dilating. Angles remain congruent when you dilate. So 3 and 4 are out. So which one is it between 1 and 2? Well, number 1 saying multiply your image by 3. So now I'm making it even bigger, right? I'm making the image even bigger. So that's why I multiply the original sides by 3 to get to the image. 2, and I'll just let you know here, I don't think I'll have enough time to watch. Oh, thank God. This one ends up being 2/3. And if you want to fill it in, it's choice 1 for number 14. Okay, choice 1 for number 14. Earphones, earbuds tomorrow, behavior, great tomorrow.